So just like Zulily, trying to stay flexible, I heard flexible a lot of times in there. Developers in a lot of different companies are trying to be as flexible as they possibly can to make sure that they can go fast and be innovative. And I think we heard this morning about containers, and sort of that's part of the mix. But you really can't forget the operating system in the equation when it comes to building a modern architecture for your application. CoreOS is a company that is getting a lot of attention lately. CoreOS is a new Linux distribution. I'm not going to spend a lot of time telling you about it because there's a gentleman that's going to come up. His name's Alex POLVI. I'm going to play the video, and then Alex is going to tell you about how CoreOS is helping people run mega scale and highly resilient applications. So let's kick off the video.
CoreOS is an early-stage technology company. We're building a new Linux operating system intended for really big server deployments. We released our first version of CoreOS around 9 months ago. Very fortunate in seeing quite a bit of uptake. The container movement has really been a good thing. And then you can think of CoreOS in a way as a container hypervisor. The architecture of how we manage servers requires a container. It requires your application to be bundled as a Linux container, and then you run it on top of our minimal, lightweight Linux OS. I think the future, when we manage things at the application level inside of a container, opens up a number of things. It opens up running on bare metal, and that being just as easy as on a cloud machine. It opens up true hybrid, so being able to run hybrid environments, of physical to cloud to multi-cloud type environments. It opens up the opportunity for developers to have control of their applications and how they're deployed in a much more seamless way than how kind of ops versus dev works today. Kind of is the next logical step post-virtualization is this move towards thinking about everything from the applications perspective. And if you do that, you get all these advantages.
With us, we have the CEO of CoreOS, Alex POLVI. He is also a former Racker. He actually worked at Rackspace through an acquisition that we did of his company, and we're proud to have Alex here today. So take it away, Alex.
All right, thank you. Boy, it's uncomfortable watching videos of yourself. But a little bit about me. My name is Alex POLVI. Like John mentioned, I was a Racker in my most recent role. I still bleed red, so Racker for life. I joined through the acquisition of my previous company, CloudKick. We built tools for cloud monitoring and server management. But my team is way cooler than I am. My team, Mike was SRE at Google. Brandon, our CTO, co-founder, was on the SEAL Team 6 of kernel development teams at SUSE. We got the guys that were running clusters at Twitter. One of our gentlemen was a major contributor to OpenStack. And we're a very early stage company. We just completed our Series A, which was led by Kleiner Perkins with Sequoia participating. So what is CoreOS? Well, it's what happens when you put all those people in a room together. It's a Linux-based operating system meant for running really large server deployments. You could call it a Linux distribution, similar to Red Hat or Ubuntu, but I like to think of it more like Android. I mean, you don't really think of Android as a Linux distribution, but that is what it is at the end of the day. But we're focused particularly on servers. So why did we start working on this? Why did, as a startup, did we start hacking on a new Linux OS? Not a lot of startups working on this. And for me, it was around primarily security. And by way of analogy, I want to talk about browsers for a minute. Who remembers in like 2003, 2002-ish, when Internet Explorer was the bane of every IT guy's existence? Remember that? There were these Patch Tuesdays. All the IT teams around the world would scramble. It was a very insecure time on the internet. Firefox came along. I was working at Mozilla at the time, and its whole value prop was lightweight, small, secure browser, simply just because the web was becoming crazy with a dominant market share of an insecure browser through IE. But when Chrome came out, it really trumped everybody. And what Chrome did differently than the other browsers is when there was an update, a patch or a security fix, Chrome would go and just automatically apply it. And so it would download and apply it without the user asking at all. And At first, this freaked out all the same IT guys. You're like, wait a minute, you can't go updating software on us automatically. But then what we found out was actually Google was better at centrally managing this for everybody than any individual IT team is. So we got nothing like this for servers. State-of-the-art for a server is get it running and don't touch it. So we felt if we could build a server that automatically updated itself, we could unlock a lot of value. And that value, it's around security, it's around performance, it's around reliability, it's around just everything that is related to running the most latest up-to-date version of a software. And so that's where we started. August of last year, we shipped our first release, and it was a little lightweight OS that updates itself, and we started from there. But what's the big picture here? What are we actually building towards? And being an entrepreneur, it's kind of the point. You're trying to understand where the market's moving and get ahead of it a little bit. And there's just been some really interesting stuff going on over the past year. I don't know if you guys have been reading the news, but containers are a pretty popular thing coming up. Containers are definitely part of the story. Docker has been doing a phenomenal job teaching us new ways to run infrastructure. But there's a number of components in here. And I've been spending a lot of time just thinking about what does this all mean? There's projects like Mesos around cluster management. Kubernetes is this thing that Google put out. The Go programming language seems to be part of this, if you're familiar with that. LXC, etcd is a tool that we wrote. I've just been really trying to figure it out. What are we all building towards? It's just a container isn't enough to run a system. And so I've been thinking about it. And I was reminded of this paper. This paper was put out by Google in 2009. It says, an introduction to the design of warehouse scale machines. Now, I'm not quite sure what that means, but it sure does sound cool. So I started to dig deeper here. And the keywords on this paper were somewhat relevant. Fault-tolerant computing, distributed systems, cloud computing. And looking around the marketing pages of these different tools, here's Docker's latest slogan, for open platform for distributed applications. Again, from Mesos, scale infinitely. And I think what's going on is we're all trying to build warehouse scale machines. That sounds a bit odd, but I think that's where the next way that people think about their infrastructure. Rackspace has definitely built a warehouse scale machine for all of us, but as just the general growth of the internet occurs, we all need to start building our own warehouse scale machine. So what is this? What is a warehouse scale machine? Well, first, before I do this, are there, who here is a sysadmin? You're logging into servers, you're wearing a pager. Sysadmins, raise your hands. Yeah, we've got a couple of them. I think this is actually probably appropriate time to do a little applause for these guys, because that's what this is all about. And actually, could I pick on one of you? There's a gentleman here, maybe in the middle in the white. Could I ask you a question real quick? Yeah, you. Yeah, is that all right? Can we get him a mic, if possible? The question is look, if you're running your server, let's say I came to you. What was your name? Ali? Ali, if I could go into your server infrastructure and pull the plug on any machine whenever I want to, and your application keeps working, would that be a good thing? The answer is yes. That's the kind of that's the kind of service we want. Now, Ollie, can your server?
But it wouldn't work. You can't just pull a plug.
Well, if you could though, would that be a good thing?
Sure.
Yeah. Okay. Now, can you do that with your server infrastructure?
No.
No. And that's I think what's going on. I think people want to be able to build these types of systems, these infrastructures where you can add more servers, get more capacity. You could pull any individual server anytime and thing keeps running. You don't think about applications. You think about applications. You don't think about individual machines. Even things like Open Compute play into this, where you have really smart software, but dumb hardware, flaky hardware underneath. And so I think most operations teams, if you talk to them, want all of these things, but yet we don't do it. And it's just simply because it's too hard. And so I think what we're really doing at the end of the day is helping you build this warehouse scale machine. And the way that we do it is by bringing in a set of components, different pieces of technology that help you do this. CoreOS is the OS required for this. Docker is how you package and run your applications. etcd is this tool that we built for it's a distributed systems primitive, I guess that's what it says up there, but it's a component for building distributed systems. Fleets, how you can manage clusters. And again, you have choices of different components for all of these different parts of the stack. But at COREOS, we're going to curate you a set and make it really easy to use so that we can all kind of build this style of infrastructure. So when is it ready? This is really exciting. On Friday, again, we launched our first alpha version last August. And on Friday, or it's Thursday, the engineers were like, hey, our stable release is ready. Wait, what? It's been like a year of nonstop work. But on Friday, we cut our first stable release. We call the base OS production ready. So we're really excited about that. It was a huge milestone for us. And we, thank you. So shipping is the best. Who's using this stuff? I thought Rackspace was actually a good one to call out. A longtime friend and colleague, Paul Querna, was one of the main architects on the On Metal platform that's been coming out. And yeah, On Metal. And it's a little confusing here, so bear with me. But CoreOS is used on the undercloud component, like the provisioning infrastructure to actually bring up On Metal servers. So when you go, say, like launch a server, what happens is CoreOS boots, it brings up the bare host enough that it can be imaged with Red Hat or imaged with CoreOS, so that would be CoreOS on CoreOS. But you boot CoreOS just temporarily in order to lay down and set up that server so it can actually run into the thing that the user requested. So Rackspace picked it up, started using it. Pivotal and Google have both released products building on top of components of ours. So in this example, they used our etcd product for building their cluster management systems, which is really exciting for our engineering team because our tool called etcd was developed based on research out of Google. Then to see Google use our product, we were like, whoa, that's pretty neat. And so definitely getting traction, but we are very early in the life cycle of a company, and we are continuing to push forward on this mission. So that is CoreOS, and thank you so much.
I think we have time for a couple of questions. Would you be willing to take a couple from the audience?
Definitely.
Anybody have questions? I see one hand. Could you get a microphone right back there? And then maybe, sir, stand up just so the camera can kind of see who we're talking to. We can't see because the lights are a little bright, but hopefully the camera can.
Hi, can you just talk about how the auto update, auto patch system works for CoreOS?
Sure. How nerdy can I get? Real nerdy?
Nerdy as you want.
All right, let's talk about partition tables. So it's pretty cool. So we actually borrow a lot of these concepts. Like, we're not inventing a ton. We're just applying these theoretical best practices and making them practical for people. So the way to apply an update on an appliance or on things like your cell phone, the way it works is it's called a double buffered update. What that means is there's actually two images of the OS down at any time. The version that you're currently on and either the new version or the old version, depending which way you're upgrading. So what happens is you boot up CoreOS, okay? And just like how with Ubuntu or Red Hat, when you go apt-get install whatever, let's say on Ubuntu or Debian, it will hit the ubuntu.com servers, and then you'll download some packages and it'll run. Similar to that in CoreOS, it checks home and it says, is there an update available? Is there an update available? And if there is, it starts downloading it to that passive block device. Now we're getting a little down there, but it starts downloading it and applying it. And then after it's passed security, it's passed validation, passed everything, then the machine flips over to that newer version. So what you get are these state transitions from you're in version A and now you're on version B. There's never an in-between. Problem with how systems kind of work today is it's all about convergence. You start at this base state and then you install and it updates, and if everything went flawlessly, you end at this end state. But if anything went wrong along the way, you end up in this dirty state, and that's why servers are really hard to manage at scale, because there's lots of servers out there with random little hacks in there. So we just changed that. It's a departure from the way that we would manage an update with a normal Linux OS today. But it also, we think, allows you to actually do this all at scale.
One more question. Anybody have any thoughts?
There's one right here in the middle.
Right there, microphone.
Thanks. Hi. So I'm going to start with an apology, because I know you're a Linux guy, and I'm going to mention Microsoft Windows. So, sorry. So if we're talking about from the Windows world with Windows Server Update Services, which where you actually filter what updates are relevant or irrelevant to your server. So what will the CoreOS do? I mean, if the management are automatic, the management updates automatically knows which updates are relevant for that server, or is there any human contact at all?
So first, Windows has its place in the world. I'm not at all avoiding that. In fact, one of our investors was the product manager on Windows 95, so we thought that was pretty cool OS. So he invested. So with updates, so essentially what you have right now with the base CoreOS is a Linux kernel as a service. And the updates that we service you are bit for bit identical, whether you are on a virtual machine on your laptop, or you're running on Rackspace, or you're on bare metal. The updates, we're servicing everybody the same. And that's where you're able to do it all automatically. If there are any like discrepancies, well, that will just double the support matrix now in terms of testing. So if we ship 2 versions, so everything is exactly identical wherever you run it now. You can customize still by bringing in your applications on top of the base CoreOS, but the actual Linux kernel as a service that we've built, that is all the same everywhere.
All right. Thank you, Alex. It's really cool to have you here.
All right. Thank you.
you.
Like this.